the last page, page 6 of the 6th grade post-course detailed answers. Question number 81 starts off with each person in a group buys a movie ticket, a drink, and a popcorn. How much does the group pay when there are 5 people in the group? So the price of a ticket is $5, a price of a drink is $3.75, and the price of popcorn is $3.50. So each person is going to buy one of these. And how much does each group pay when there are 5 people in the group? So 5 people. So we can do it a number of ways. We could either total this up. That would be the easiest way, is to total those costs up. That's 6, that's $7.25, that's $12.25. You could do it in that way. That's sort of like a package of a TDP, ticket, drink, and popcorn costs you $12.25, and you can multiply that by 5, and that would get you 25, and that would get you $61.25. See, that's what knowing multiplication does for you. Or the other way you could do it is you can do 5 times $5 plus 5 times $3.75 plus 5, we'll put that in parentheses there, 5 times $3.50. And that is going to give you $25. That's going to give you, I see that one I can't do in my head. 75, I have 5 75 quarters. That's $5 minus $1.25. So 15. That's $20 minus $1.25. So that would give you, what's that, $18.75? Don't know if I'm doing this right. This is the problem with doing in your head, though. And then 5 times $3.50, that's $2.50 plus 15 is $17.50. So that gives you 25. That's going to give you 8 and 8, 16. 21, 2, 3, 4, 5, 6. Yeah. I got it both ways. So you can do it either way. 5 for each of those, or you can total up and multiply it by 5. That was question 81, $61.25. Boom. All right. Mrs. Poole told me that you guys struggled with this all year. So you have 2 quantities that you're subtracting. So you're taking this from each of it. So you have to distribute this negative. This is a -1 outside of parentheses. We have to distribute because it's the opposite of 1/2 x. Well, the opposite of 1/2 x is -1/2 x. And this is the opposite of -8, which is +8. So notice we distribute that -1. -1 times anything is going to change its sign. So we have a +1/2 x now becomes -1/2 x. And this quantity is just separating the two. There's nothing happening here. This negative gets distributed to the right. Nothing. All it does is it removes that parentheses because now it's not grouped anymore. So 3x or 3/4 x and -6 just come down. Now we're going to combine like terms. So we have like variables, and we look at their coefficients. 3/4, -1/2, leaves us with 1/4. Hopefully you know, and that's 1/4 x. Hopefully you know that 3/4 x minus 1/2 x will get a common denominator of fourths. And so 1/2 is equal to 2/4, which is equal to 1/4 x. And then we have our other group, like terms, they're constants, and that's going to give us +2. So that simplifies to 1/4 x plus 2. 1/4 x plus 2 is correct. Another one, so we cannot combine these like terms. These are like terms, but we have multiplication, so we can't do addition before multiplication. And we can't even get into these. These two can't combine because this is a variable, this is a constant, but we can distribute this 1/4. We need 1/4 of both of these quantities. So mathematically, 1/4 of 12x, and we need 1/4 of 12. And then we're going to take that and we're going to add it to 8x. 1/4 of 12x gives us 3x. The 4 is in the denominator. It's going to cancel with the 12 in the numerator, which is 3. So we get 3x. Again, the 4 in the denominator cancels with the 12 in the numerator. 4 goes into 12 3 times. And then we have 8x. So these are like terms. We're adding across, so we can use the commutative property of addition. These are like terms. We're going to combine their coefficients, 3x plus 8x. If I had 3 X-ray machines plus 8 X-ray machines, that would give me 11 X-ray machines plus 3. And these are unlike, because these are X-ray machines and these are dollars, and dollars and X-ray machines don't simplify to each other. And remember, we put it in standard form. The variable comes before the constant. Factor 1/4 out of 1/4 x plus 3/4. Okay, so we're going to turn these, when we factor, we turn them into products. And I'll show that. So that's multiplication between these two. And then 3/4. Okay, 3 times, or 1/4 times what would give us 3/4? So what times 1/4 would give us 3/4? Well, the 4 is already taken, so I would need a 1 in there. That makes that. And then what times 1 would make 3? 3. Yeah, 3. So that missing number is 3. So if I write 3 times 1/4, or let's do it the other way. Let's do 1/4 first. Sorry. Let's break that into 1/4 times 3. So if we factor it out, it has a common factor. It has a common product. So if I pull that 1/4 out, and if I remove it, do you see what you're left with? X plus 3. If we remove that, and let's sort of show that removal part. So if we remove the 1/4, you see what you're left with? X plus 3. Yeah, that's called factoring. Yep, kind of cool, right? It is a common product. And then that's what you would get. 1/4 times the quantity, x plus 3. And if we distribute it back out, you get 1/4 x plus 3/4. A person jogs 1/7 of a mile in 1/56 of an hour. What is the person's speed in miles per hour? Okay, so we're going to create a 1/7, and we're in miles per hour. This is important. So we have miles per hour. So miles is going to go in the numerator. Hours is going to go in the denominator. And we want to know, hey, how many miles per 1 hour? So we can use cross product here. So we'll multiply those two. We'll multiply those two, and then we will solve it. So we're going to write an equation. So we have 1/56 times x equals 1/7 times 1. So 1/56 times x, we can just say x equals 1/7. We want to isolate the variable x. What's happening to it? 1/56 is being multiplied by it. So if we want to do the inverse of multiplication, remember in that earlier video I said the inverse of multiplication is division, but it is also multiplying by the reciprocal. So I'm going to multiply both sides by 56. Denominator cancels with the numerator, leaving me with x. This 7 is in the denominator. What goes into 7 and 56? 8. So we get x equals 8. Okay, that's not the answer, because X is definitely 8, but that's my miles. So 8 miles per hour would be the speed that that person is traveling. If they, or excuse me, jogging, if they travel 1/7 of a mile in 1/56 of an hour, they would be traveling at 8 miles per hour. Pretty fast jogging. Tell whether 25 to 2 and 3 to 8 form a proportion. So 25 over 2, does it equal 3 over 8? And remember, cross products of equivalent fractions will always be the same. So 2 times 3 is 6. 25 times 8 is 200. How did I know that so quick? Well, there are 4 quarters in a dollar, and if you have 8 quarters, that's $2 or 200. So these are not equal, so they are not proportional. Are not proportional. '86. A graph shows the speed of a vehicle where x is the time in minutes and y is the distance in kilometers. The graph is a line through the points 1, 2/3 and 2, 1 1/3. Find the speed in kilometers per minute. Why do I need 2? I don't know why I would need 2 points. Why do I need 2 points? Well, right? I mean, once if we've got time over distance, and that time, oh, that's tricky. So x is time, so this is time, distance. So here we're distance time, so be careful of that. That was a little bit tricky. So isn't it, and these are in minutes and kilometers, so wouldn't it be 2/3 kilometers per minute, per 1 minute? So the speed is going to be 0.6 kilometers per minute. That wasn't really too tricky. 87, how do they want it? No, they want 2/3 kilometers per minute. They want this answer. They don't even ask it for a decimal. Yeah, that information was there. I didn't have to do anything. So it was there if we took the time to comprehend the question. So be careful of that. That's a good tricky one, but that was kind of easy. Write an equation for the proportional relationship shown in the table. Okay, so when we write an equation is going to be in slope-intercept form, or at least y equals mx plus b. And here are x values. So we want to find the slope. And remember, slope, you have x sub 1, y sub 1. You have x sub 2, y sub 2. So your formula for slope, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y sub 2 is 74 minus my y sub 1, which is 37, over x sub 2, 1 minus 0.5. So that gives me, what's that, 37? Over 0.5, which simplifies to 370 over 5, because I moved the decimal point 1 place. I have to move that decimal 1 place. And now 5 goes into 37 7 times with 20 left over. So 74 is going to be my m. So I can substitute that in. My equation now is y equals 74x plus b. And just to make sure, remember, we fill in, when we fill in slope-intercept form, you fill in for the slope and the y-intercept. The y-intercept and the slope. So we just found the slope, and now we have to find the y-intercept. So I need to find this value. Do I know an x and a y? Yes, in fact, I know 1, 2, 3, 4 x's and y's. So I'm going to pick one of these sets. Let's use 1 and 74. So y is 74 equals 74 times 1 plus b, and we're going to get 0. That's interesting. I don't know why that would be. Do I want to use that? Yeah, still get the same value if I do it the other way. So we'll subtract 74, and we get 0 equals b. So the equation is just going to be, so now we take that. We know b is 0, so y equals 74x should be the equation. Now I can test it. I can plug in 2. Do I get 148? Yeah. If I plug in 1, do I get 74? Yes. Plug in 0.5. Do I get 37? Yep. So 88 is write an equation for the proportional ratios. Well, that's it, but it says k equals 38. What? No. Sorry, y equals 74x. Next question. You already know the answer. Sorry. Yeah, this is correct. All right, find a constant proportional, yes, the k, y equals 38x. Well, that is understood that y equals kx when the constant varies proportionally. So if we have the equation, this is my k, so k equals 38. I didn't have to do any work. And then if it is inversely, it would be y equals k over x. X would be in the denominator. So that's an interesting one. So that's a nice way. Direct proportion or direct variation varies directly or indirectly. A scale drawing of a square has a side length of 2 centimeters. The drawing has a scale of 1 centimeter to 8 feet. Find the actual perimeter and area of the square. A scale drawing of a square has a side length. So this is actual to scale is typically how they do it. So find the actual perimeter. This is, okay, so the scale value, so scale to actual. So if the actual is 2 centimeters, so 1 centimeter to 8 feet is the key, and we're going to see, hey, it's 2 centimeters, so we know that we're going to multiply that by 2. We have to multiply that by 2, and we get 16 feet. So of a square, so my square is going to be 16 feet around. So the perimeter of a square is 4s because you have 4 sides. So if we substitute 16 feet in for s, that's my side length, that's going to give me 64 feet. Notice it's to the first dimension, to the first degree, because perimeter is a distance. And then if we want to find the area equals s squared. That's the formula for a square. So that is going to be 16 feet quantity squared. And 16 times 16. Hold on. Yeah, I was going to say 196. Is it 196? I kind of think it's 196. 16 squared. 256. Not even close. 256. Let's make sure I did that correctly. 16 squared. Yep, that's correct. All right, 256. So 16 times 16, and then you have feet times feet. So you have feet squared. So your perimeter is 64 feet. Your area is 256 feet squared. Write 76% as a decimal. So there's two ways. You can have 76%. You can move the decimal point 1, 2 places, and you get 0.76. The other way you could do is 76% is equivalent to 76 over 100, which is 76 hundredths. Either way is good. This one tends to be the quicker way. Write 0.51 as a percent, 0.51. So we're going to move the decimal point the other way now. So that equals 51%. Now the other way you could have done this is 0.51 equals 51 over 100. And that is equivalent to 51%. Those are two nice ways. You estimate that there are 66 marbles in a jar. The actual amount is 89. Find the percentage of error, round to the nearest tenth of a percent. Okay, percentage of error. So you have 66, in 89 minus 66. And that is going to give you 23. I think it's 23. Yes, 23, 2, 3. 23 is your amount difference. And then the tough part is which one are you going to use as your original? Well, your original has to be the correct one. It's 89 marbles. And so now we're going to find the percentage of error. So I'm going to divide 89 by 23. And doesn't go in 23 times. 230 is probably going to be about 2 times. What's 89 times 2 is 18. 8, 8, 16, 17, 178. What would 89 times 3 be? 27, 24, 25, 26. Yeah. So that's going to be 2 and 178. We're going to subtract that. That gives me 2. I got to borrow. And that's 7 from 12, which is 5. Add a 0, bring it down. 520. So let's do 89. That's going to be at least 5, maybe 6. 5 is 45. Is 44, 4, 5. Well, we're going to try 6. 6 times 9 is 54. 6 times 8 is 48. Plus 5 is 53. Oh, 648. Yeah. All right. So it's 5. So 4, 4, 5. Borrow. That's 5. Borrow. That is 7. So I knew that was correct. I'm going to pull that down. Add a 0. So I'm rounding to the nearest 10th percent. So I'm in decimal form. I got to go way out here because when I move it, I want to go to the 10th percent. And then I got to look at the hundredths to know if I'm going to round my 10th percent. So we got a ways to go here, kids. 750. So let's do 89 times, well, let's do 7, right? 7 times 9 is 63. 7 times 8 is 56. 62. 89 times 8, 72. 64. 71. Whoa. Okay. Yeah, definitely 8. Okay. 712. 712, right? 72, 64, 7, yeah. That's going to borrow is 8. Borrow is 3. Add a 0. Bring it down. 380. 380. And of course, 4 is right in there. So we had to do 89 times 4, which is 36. That's 32, 35. Yep. See, thank goodness. All right, but I don't have to do any more. I don't even have to do this. So that's as far as I need to go because my decimal value, let's do this down here. My decimal value is 0.2584, I think we said. So if I move my decimal to turn it to a percent, 1, 2, and that value now is 25.84%. And remember, it said round to the nearest tenth. So I had to go out to that value to look to see if I'm rounding it to 8 or 9. So my answer is going to be 20. That's a horrible 5. My answer is going to be 25.8% error. And is that correct? Duh! What? Oh, 51. What? What number is this? What number is this? 93. 25.8%. Woo! Good. I was going to say, I did a lot of math. Number 94. 2 more problems. Find the selling price of a $50 item after a 50% markup. So, this is a little bit of a mental math, kids. We're going to take $50 and we're going to multiply it by 50%. That's how much we're adding on to it. So 50%, we don't multiply by percents. We have to change it to a decimal. So 50% as a decimal, we would move that decimal point, 1, 2. So that is equal to 0.5. Everybody should know that anyway. 0.5. And 0.5 is just like 1/2. So you get 25. So 50%. So this is the markup. And we have to add it to the original cost, because your cost plus the markup gives you $75. This is the original cost plus the markup gives you your total of $75 is the cost after the markup of 50%. You deposit $300 in a savings account. Excuse me. The account earns 1% simple interest per year. What is the interest earned after 3 years? The balance after 3 years. So interest I equals PRT. Interest equals principal. I think it might be PLE times the rate times the time. You never want to lend on simple interest. You want to lend on compounding interest for all you financial kids. I actually thought about doing a summer finance course for students. So your interest is going to equal your principal. This is going to be your principal. This is going to be your rate. And this is going to be your time. Sorry. Yeah, well, 3 years the same. So interest equals principal, $300, times your rate, which is 1%. Now let's again, 1%. The decimal point is there. I'm going to move it 2 places. So that equals 0.01 as a decimal. Times the time, which is 3. Interest equals, so that's going to give us $9. Ugh. That is so unfortunate. 9. So the interest after 3 years is $9. After 3 years, or for 3 years, not after, for $3, $9 of interest for 3 years, and then we were going to add that to the balance. So we add it to our principal, which is $300 plus the interest, $9, gives us $309 balance after 3 years. So this one's the after 3 years. So this is the principal plus the interest, and there you have it. So that is simple interest. This is the simple interest formula. Pretty good. Good stuff for 6th graders. I mean, there's some technical stuff, but it's always good to review it, keep it fresh. You will have questions like this on your HSPT, maybe even an SAT question. So good luck. You are done with 6th grade material. We are going to move on to 7th grade.